So I won't waste time in getting us started on what looks like a really exciting talk. As such, I'll keep this to a minimum. Ladies and gentlemen, allow me to introduce Michal Swapa of CD Projekt Red, talking about The Witcher 3.
Hello. It's a pleasure to be here. Actually, it's a pretty weird and pretty hardcore kind of pleasure because I feel a little stressed. But, well, nevertheless, it's a pleasure. And my name is Michal Swapa. I'm a principal AI coder at CD Projekt Red, and I will have a privilege to talk to you about Witcher 3 Wild Hunt community system that we call Spavin Tre. And in a moment, I will quickly run through a project with you and show you one of the challenges we are facing during the development. And with this, I will take you on a road that actually led us to a solution we've got now. And with solution on hand, I will try to give you a recipe to make it more or less a complete solution in your view, in your mind, okay? And after that, there will be some time for a summary, for some kind of a broader look on the subject. So yeah, so The Witcher 3. The Witcher 3 Wild Hunt is a dark fantasy RPG that is set in massive, handcrafted, open world environment. It's story heavy, and it's a world where your choices as a player do matter, and you will feel the consequences both through your story and through the environment around you. And actually, these features here are not without a reason. They all have an impact on a system we will be talking about in a moment, okay? And basically, Witcher 3 Wild Hunt was bigger, better, and more badass than everything Witcher games were previously. So yeah, so let's go to this community system. And as a community system, I understand something that actually takes care of all the spawning. And because it already has to spawn NPCs, it usually has some kind of high-level control over them, so it knows who should be where and doing what, yeah? And actually, what's the hassle, you can ask, yeah? I mean, it's not... you wouldn't expect actually anything sophisticated under the hood of a more linear game where you actually doesn't need to have something more here, but we were doing an open world game and we needed an open world community system. And this system had to be suitable for, for describing the large city of Novigrad, but also for describing a small, almost abandoned woodcutter hut in the middle of nowhere in no man's land swamps. And the same system will fill the lush forest with the wildlife, both these natural, like prey and predators, and unnatural beasts as you are a monster hunter. And the same system will describe some, dungeon filled with undead gods that are, guarding some kind of forgotten treasure. And on top of this, we want to enhance our ability to tell the story through environmental storytelling, okay? So with this comes actually a complexity, requirement of complexity. We have a huge world to populate, and our communities are meant to be believable. They have their own day-night cycle, they are reactive, they are interacting and acknowledging you as a player, but they are also mutually interactive. NPCs goes into some kind of more or less random interactions between each other to break up the monotony, okay? And on top of that, we have a multitude of custom behaviors we would like to use here, yeah? And we want to craft some small, memorable points of interest for you to remember as a player. And at the same time, we want to fill this world with tons of enemies for you to slay. And actually, these enemies have to be balanced somehow, yeah? And with this comes requirements of flexibility, yeah? We would like to have a single system that will be able to spawn community, control it, and script it all in one place. And we would like, as you already see, there's a different environments. With this, there are different pipelines and different requirements you want to use with the system, yeah? So actually, in the end, there's different teams of different type of people working in these teams, and they will require a little different pipeline. So we would like to give them a tool that they will be able to, wrap up for themselves so that they will be able to create a pipeline. Not you as a coder will have to code them everything by hand. And this system has to fit nicely with AI for control. It has to fit nicely with the quest system for storytelling and with the gameplay systems. And with gameplay systems, it has to go both ways. Think of a very simple example of a portal, yeah? You have a portal, because of some events, it's activated, so it starts spawning NPCs, yeah? But if you kill all the NPCs, it will stop the spawning, yeah? So the portal has to communicate both ways with your system. And actually, if you would like throw some special bomb into the portal, it would also deactivate spawning mechanism. So again, you have to reach somehow to this community system, okay? So we see the scale, we see the requirements, and time for some story, okay? Actually did pick up this shot not without a reason. It reminds me of Kermoren. It's a place that wraps up Witcher 1 and Witcher 3. And actually the system I will be talking about shortly has its roots in Witcher 1. Witcher 2 community system, you know, it's much more than that about this, but basically it's easier to look at the system from a data side. And from a data side, for designers, they were creating lists of this thing we could call spawn entries that was wrapping up some kind of entity template, yeah? And the spawn entries could be in multiple spawn phases. So some kind of states that are externally controlled, yeah? So probably usually the quest system was setting these entries in phases, and each phase contains some kind of a timetable, so it's setting up the daily routines for characters, yeah? And actually we did use this system for Witcher 3 in some limited parts for a team that already has a fixed and a cool pipeline, okay? Here are actually a setup for 3 tasks you will meet in Winebridge village on the start of the game. I don't want you to read any numbers or text here, it's not that important. I would rather like you to see the scale of the data. Actually, here is the spawn phases and spawn entries and the timetable here. But, well, this system is suited for some specific use cases, yeah? Actually, it was designed for towns and village setup. We use different system for this right now. But it set up some kind of a pipeline, which is quite cool. And the structure is rigid, okay? But there come problems when you want to extend it, yeah? And even a small feature you will add to such system will end up as at least being a new table field, yeah? So your table will grow and grow a lot during the development. So it's easy to pick up, it's easy to start with, especially if you have full vision of a solution you want to achieve, but it's hard to maintain. Such systems usually ages badly, yeah? So, and it leads to game-dependent code being mixed with general system code because of this flat structure. So, yeah, it's something that's also not very good. And because this is a system that is rather executing, it's hard to hook it up with other gameplay systems, yeah? Hard to create some kind of a general interface. But it worked well for Witcher 2, and very similar system was working well for Witcher 1. But for Witcher 3, we just had no clue how to tailor it up for our requirements. Oh, sorry, I forgot to edit out this slide. Actually, I didn't. You must believe me that it's for a reason here, as I would like to get a little informal with you. A story I have to share, this cool story, is not something that we should be extremely proud of. But imagine we are in like maybe 1/3 of development, something like vertical slice build, and we are in the same state as my current presentation. We see the scale of things we want to achieve, we see the scale of the game, we see our previous system, and we just doesn't see these two things fit together, okay? And now forget about it. And imagine that small AI team, me and my colleague, are tasked with a very simple task to revive some small system from Witcher 2. It was called Encounters. Encounters was an entity you can place on a level. It has some volume-based trigger and an array of entries. It sounds familiar. And, well, each entry is wrapping up some kind of a template. It has some kind of quantity and identification of spawn points. And And when you come into a trigger, when you enter the trigger, it starts to spawning entries with the templates, with quantities in spawn points, okay? So it's pretty simple. So our designers thought, well, we could use it for populating more world with monsters and animals. And yeah, they thought about adding some kind of a conditions to it. So, you know, daytime condition, weather condition, witcher level condition, game difficulty condition, quest progression condition, and it, you know, it's something that you would expect to be iterated upon, yeah? And when you are tasked with adding such game-dependent code to a general system, it usually should light you some kind of a red light. So yeah, we started negotiating with the designers. We came up, you know, this condition should be something more general. Maybe you can then, you know, we will be able to add you some later, and maybe you could even script some for yourself. And well, basically we could, you know, turn it over. Actually, you should first check for the condition and then attach entries to it, because usually it's like, you know, if the witcher level is lower than 10, then spawn these guys, and if it's higher, spawn these guys, yeah? And actually, it took more than that. We actually iterated over the idea from time to time, and each step we took actually led us closer to complete solution for community system. And here, behold the spawn tree. Spawn tree is a tree that spawns. Oh, well, actually it's player now. Okay, whatever. It's all on this thing. Whatever. It's a decision tree. It's also volume-based, so it works like this encounter things. You enter and it starts spawning, and in the nodes of this tree, you are processing this logic. Yeah, let's call them nodes. And in the leaves, as every tree that is not a needle tree has a leaves, you have a thing called entries. So yeah, let's call them entries. And they are responsible for spawning. And entries can be somehow decorated with things called initializers that do all sorts of crazy stuff, but we'll talk about them in a moment. And well, the tree structure, this higher level of a tree, contains all the nodes you probably already know as being AI programmer. So all selector-like nodes that control the flow of the logic, conditions that are the good point to introduce scripting here, and some kind of meta nodes, at least the tree inclusion, so you can include one tree within each other. And you have here you have an example. It's quite typical. I tried to pick up the slides from all these illustrations from things that are actually in the game. Some of them are artificial, but I tend to use real one. And yeah, the tree usually looks more or less like this. So they are not very deep, rather wide. They fit nicely with the panoramic screen. And these brown and yellow things, they are the nodes. This brown thing here is an interface for a quest system. These yellow things are some conditions, I don't know what. And green things are usually the leaves. Yeah, so this is this entries we are talking about. And blue ones are initializers, and this purple thing is something I will talk briefly at the end. It's some kind of a meta node, yeah? And let's go for this entries. It will be quick, I think. It just crashed. Okay, we are almost there. Our cool movie. Maybe now we can watch it, yeah? No, let's not waste time. We can move forward. Okay. Okay. We are here. Okay, so let's go for the entries. Entries are these things that do spawn. They work on things like creature definitions that wraps up entity template. And we tend to keep them clean. So actually they should have as little properties as you expect. It should be something as much general common as possible. It's not a religion. Yeah? Our entries are populated with some properties that are here for legacy reason or for usability reasons. You can see the properties of our typical entry on the left. This is an entry, and on the bottom line, I hope you can read it, is a definition wrap-up. So it's something that wraps up the entity template with some abstract name you can use in your spawn tree. And also we can do some kind of overrides, from a template, but we tend not to use it. We rather use initializer for them. And here you also have an entry, but this one is more complicated. It's actually 4 guys, not one, who are a team of soldiers, outlaw soldiers patrolling a land, and they are going some kind of a formation. So 3 guys are following through the formation, their leader, and he's patrolling some area, okay? So the party is just like a subclass of an entry. Sometimes you want to treat a group as a group, yeah, and spawn them together and despawn them together, because they don't make much sense without you. Wouldn't like to meet just 2 soldiers because you despawned their leader, yeah, because he was far. Okay, and well, so now these blue things, yeah, initializers. You already saw them here a lot. Yeah. Yeah, so they are doing all sorts of crazy stuff. And first, there are 2 main areas they are responsible for. One is to modify the spawning mechanism. So they can configure spawning properties, configure the spawning properties. They can block spawning at some points. They can monitor creatures for being killed or spawned. So then you can script it somehow. For example, you can have a spawn limit that you push on a higher level of a tree for an entire tree branch. And actually, they can be applied on a higher levels as well. And well, the other thing they do, they are often modifying the spawned entities. So with this, you can have the same entity template customized at the level of a spawn tree. And well, here you have an example setup. This entry on the bottom left, yeah, it has 7 initializers, 4 of its own, and 3 are, pushed inside from a higher level. Okay, and on the right, you have our class hierarchy for initializers. Only few classes are collapsed to make it fit the screen. But you can already see that we are using it to customize our AI, that we are introducing this interface to scripts, that we are talking some AI behaviors with this, configuring the spawning, we are monitoring creatures for being killed, and doing all sorts of other crazy stuff. And, well, let's move forward. Yeah. Let's move forward. Actually, you got the basics now. And it's time for first wrap-up, first summary. And for me, moving from Witcher 2 community system to spawn trees felt very much like moving from finite state machine to behavior trees. It was same kind of problem and same type of solution. Problems arise from this flat structure, from the system growing in time, yeah? And the similar approach for this system, when you have an initial working example pretty fast, but as the project grows, as you add the features, it's getting more and more complicated. Yeah? And yeah, and now it's a moment for a recap. I will quickly run through most common features you will have to do to make it a more or less complete system. So first is how to integrate it with AI. And for this, we are usually doing one of 2 things. One is we have a special node in our AI that you can inject idle behavior. Idle behavior is the things that they do where they have nothing better to do, yeah? And yeah, so that's the one thing. And the other is we sometimes just activate, deactivate some of their high-level behaviors. Here you have an example. This highlighted node on the bottom left is the most general and most commonly used node. It's enabling you to pick up any behavior you like, and set it for a creature. Here you have the properties of this node. So you can see that it's having some kind of CA wonder tree. So actually that's a wonder behavior. And you are selecting the properties for this wonder behavior here. And next you have some kind of a siren enemy, siren. And it has the very similar node. This free flight is actually setting up a idle flight behavior for her. And this toggle can flight is actually toggling flight behavior on. But we can use this other toggle nodes that, for example, enables or disables monster ability to, I don't know, search for food, okay? And well, we already know how to pick NPCs to spawn. We already know how to make them do something. And now imagine we are in the middle of the field. And it's 5 p.m. right now. And we see a farmer plowing the field, okay? And, well, the time passes, and his entry gets deactivated. So we actually shouldn't despawn him, yeah? We should make him do his stuff still, because we have him on a camera. So we attach him to something called detached pool. Yeah, so the guys whose entries got deactivated are attached to the detached pool. It's a base of our despawn mechanism, okay? And but now the new entry gets activated. So before we let any entry spawn anyone, we run through detached pool, and for detached creatures, we try to find best matching entry for them. So in this case, this guy who was plowing the field will have a new idle injected, and this idle will tell him that he actually wants to go to sleep at his house, so he will do so, okay? Yeah, so it's a pretty simple example, but it shows that we require a little more from initializers. They don't only modify entities on a spawn time, they can also modify entities in a runtime when they are reattached. And because of that, they also need an impact, possible impact on a decision if entity is suitable for given branch, for given entry, okay? Well, and let's quickly run through spawning logic. So it's nothing that I would, nothing extraordinary, but we are spawning creature based on range and visibility queries. For this spawning, we are rather first, we are using this detached list. So guy who is on the detached list, after some time, we are starting to monitor him. We checked for range and visibility conditions, and if they are met for a certain time, we despawn the guy. And with initializers, we can get even some kind of custom behavior here. So imagine that we have a worm-like enemy, and if he is close enough, and if he is in view, we will force him to do some special AI action, like play an animation of going under the ground to despawn him. Okay, but in a city-like scenarios, it's getting more complicated because we are running out of our creature pool, yeah. And so in these cases, we are enabling the pooling mechanism. In the base, it's pretty simple. We are trying to despawn enemies that are far to spawn others that will be close, yeah? And we are actually using the same guys, just reinitializing them. And here is a typical setup. Usually, we set up the spawn strategies very high in the spawn trees, often on the highest level. So usually it's a different initializer for setting up the spawn strategies and for setting up spawn points that the guy would use. And here we have an example that we try to guess the player movement direction and spawn guys rather in front and despawn them rather at his back. Okay, and here is very important subject, last of the features I would like to discuss now, but it's really important because if you won't think about it on the start, you won't be able to address it properly, as resource sharing usually requires a lot from our core architectural point of view. So yeah, we can include trees within each other, and you will see that it gives us a lot. But we still have a problem issue that we cannot modify the included tree. Yeah, there are workarounds for this thing. We mainly use these high-level initializers to push stuff inside included trees. Yeah, and sometimes we have some data on entity level, but still it leaves our resource sharing somehow limited, and that leads to at least data redundancy. Okay, and here you have an actual example of a living world setup. Here you have for a living world team, usually we try to split the work. Some of the people are creating huge ass volumes for encounters and then pushing and areas for particular groups of monsters, animals, bandits to appear, yeah? And then in a spawn tree, they are just including, these red things are include node, including common templates for encounters of these enemies, yeah? So, for example, they are setting up a hard wolf encounter, and hard wolf encounter has 4 wolves and, and 1 mini boss wolf, yeah? So with this, you can balance out the things, and at the same time has a customized encounters that fits the environment. And yeah. And well, yes, it's time for some wrap up, for some summary. And we will start with the cool things, what worked well. And first of all, we have a game-specific logic done by a general system. It's scalable as it doesn't collapse with all our iterations, and and it's extendable, especially if you can create a new node to have a new feature, and customizable a lot. And it nicely connects AI. It nicely connects with the quest system, with other gameplay systems, and it encapsulates nicely NPC spawning and controlling them, and this environmental scripting we were talking about previously. And it supports resource reusing and some kind of iterative development with this. But it still has some kind of issues. I would just like point you out our main one. First is redundancy. Here is a quite extreme case, as you have a day and night setups at the same place. So you have almost the same structure, but then there is some differences. This thing, actually, you could target differently. You could have in your entry, like with this farmer, you could have 2 like initializers groups that, one is for day, one is for night. But still, as you will have different teams that will encounter different problems with your system, they will all create some kind of a internal pipeline for dealing with them. As you saw this living world setup, yeah, which was, you see the pattern. You saw the pattern on the screen, yeah? So that's one thing. And the other, actually one of the things, these purple nodes, yeah? They are actually one of our small touches, small answers to a problem. So you feel them as a table. You feel them as a table of data, and they are creating entries, list of entries with initializers and stuff, yeah? So they are some kind of shortcuts. But still you end up with a tree structure that is describing sometimes these data are quite flat. Yeah? So if you have no much logic for a tree to process, then, well, you are, it looks like a tree sometimes are a hassle. And for sure, there are solutions for this. You can try a multitude of things. I would love to tease you with things we have on mind. Actually, there was a lecture yesterday about parameterization. I do think it's an extremely important thing, and it's important that it should be, supported by the core system. And so what we think is we would like to extend upon resource sharing. So imagine that each resource can also define some kind of a list of parameters that then, when you are referencing the resource, you provide these parameters. And with this, from a single resource, you can create multiple, let's say, compiled instances of this resource, yeah? Which is parameters you are getting, for unique parameters, you are getting unique compiled instance of this resource, yeah? So with this compiled instance doesn't even match one-to-one, you know, resource node and instance node. So it's a thing that we have in our AI and we are really missing in our spawn trees. And with this, your subteams can create for their own building blocks for the pipeline. Yes, and also here we have an actual example. Let's get back to the slide about AI integration. If you would look at this thing, it's some kind of CAI wonder tree object that is attached to a property that required CAI idle tree. So CAI idle tree, you can think of it as an abstract reference to idle tree resource. And this CAI wonder tree is our reference. It's under the hood, it's just a reference to a wonder tree resource that requires you to fill up the parameters that are valid for this given resource. Yeah? But as I said, I would just like to tease you with this and push forward to other closing thoughts. As well, I would love it to be some kind of starting point for your future R&D. It's not like that for every game it's a good solution. It's a good solution if you have open world game and you want to have reactive custom community. Yeah, and it's complete solution, but it's not yet matured. There is so many things you can do better, you can iterate upon, and I would love you to do so, and maybe reach me if you do something better, you know. And it's also, from a broader look, it's example usage of very AI-like architecture outside of the AI itself. We as an AI programmer are often very used to working with the trees. It's sometimes a moment to give it back and give designers new tools, custom designer tools that will allow them to set up customizable and complex system with mostly designer-friendly tools. Okay? Actually, the main idea of decision tree is extremely simple. You know, it's just about making a complex decision with multitude of hierarchical but simple decisions. Yeah? And for Witcher 3 Wild Hunt, we had 3 systems that share the same tree editor code. It was a steering graph for the movement, AI tree for AI, and spawn tree for spawning. And with the next iteration, we would love to have even more systems that will share not only the editor code, but also the general core system code, as we would like to natively support at least the parameterization. So we will have a moment for questions, and there is a separate QA session that you can join me in. I encourage you to. Yeah, how about the questions?
So thanks for the talk. How comfortable were the content creators with using the system? How comfortable were the content creators with using the system? How do they like it? What did you have to? What was the road for them in terms of using the system, basically?
Yeah, one thing that is crucial is that there was different teams and different type of people working with this. So it was very cool for guys setting up this living quote. It was quite cool for Quest guys who were able to come up with very custom situations. And for a city-like environment where you have actually multitude of these entries, you have multitude of guys to spawn, and the logic is, there is a logic usually, there is much branches, but you know, the structure of it wasn't, they needed a little help with this. But yeah, I mean, for sure, for me, hiding the tree under some kind of abstraction barrier is a step forward we would like to take.
Hi, thanks for the talk. How do you persist gameplay information in your encounter system? Or do you persist any kind of gameplay information in it? Like if you have an encounter with a party and you kill 2 of them and wound the other.
Okay, so there is few options. First, there is this, we have some custom initializers, for example, that saves how much of your guys in a given branch was killed. And basically, entries themselves, they have a support for saving such numbers. Also, there is some other custom initializer that, for example, says that this guy from this entry is not a random guy that you will despawn and forget about him. This guy will fully save, like for example, a merchant who is spawned from this system. He has like some kind of a persistent ID that will make him save. Yeah, and also there is often some more custom cases. For example, we have cases where, imagine you have an open world area and there is some kind of, I don't know, village or a large piece of large forest, and there is multiple groups of monsters there. And if you kill all of them, we will spawn a special group of monsters, like with boss and stuff. And if you kill them, then you will have some special treasure. So we sometimes use this system for very custom stuff, very game specific. And in this case, for example, I don't know how it's made. These options that you know, that it contexts, because it was done purely by designers on the script side. So yeah, I hope I more or less answered your questions.
Thank you for this talk. I was wondering, would it be possible to add some constraint or maybe helpers for the creators, such as, for example, you can't spawn 10 people in a room, or do you have something to prevent, to write bad trees, in fact?
Yeah, first of all, from a constraints. For example, we are not allowing initializers to be conflicting each other. Actually, we are using this feature even in runtime when we are composing the tree from this high-level initializers into these entry-level initializers. There is special logic that says that if they are conflicting, we are picking one of them depending on some setup. Yeah. That's one thing, and yeah, I mean the structure is quite clear. Yeah, you have to know what it's doing, but.
Hey Mio, thanks for the talk.
Okay.
So to follow up on your answer now, the one you gave just now, I was wondering if like a designer requests 10 entities being spawned in a room, but you don't have resources for that. You can allow like 6 or 8. Do you spawn like as much as you can, or you don't spawn at all?
Okay, so
or if it's an option.
First of all, the main issue with spawning who you want is pooling this limits for creature numbers. So usually the super important creatures that are quest dependent, they spawn with some special priority. They will spawn nevertheless if it's possible, yeah. And then we will just, if we are over the pool, we will despawn. We'll more aggressively despawn guys. We will more aggressively pull them.
Okay, and another question is. So as far as I understand, those spawn trees are defined per like encounter, which is like an area or something. And I understand those trees are part of like configuration of this specific like location. But can you reuse the spawn trees so that you can say like, well, this event is just like the other one?
Yes, but with this limits. You can reuse it, but then you have to actually, there is a hassle to configure it from outside, yeah? And, well, there are workarounds. We have some, probably you can find others, and for us, the answer would be to parameterize these encounters, and with this we can have a more, a spawn tree that's a little more general and just accepts the parameter for spawning time.
Yes, we have a question on the stream from Phil Carlisle, who asks, He says, I noticed in your property views you had quite a lot of classes. Does your engine use a lot of inheritance? Do you think a component-based engine would make this kind of system easier to create, as it already based on hierarchy of properties/code?
Actually, if you would, I think he was referencing the initializers. If you think of initializers, they are very much like components. They are enclosing some functionality you want to from the spawn tree, from the spawning system. So they are either extending upon a creature, modifying it somehow, customizing it, or scripting or customizing the configuration of spawn. So they are very much like components, because you can create like a multitude of initializers that actually, fit together and change the different aspect of a problem, yeah?
Okay, well, that's us. I'm afraid we've got to move on, let the cognitive track come in. We will be downstairs right after this if you want to come and have a chat with Mikael, but let's thank our speaker once again. Thank you.